So I'm Grainne El Montassir. I am a reader in the Department of Civil and Environmental Engineering, and I'm our Director for Research as well. So I think really one of the main challenges moving forward is decommissioning. And so the nuclear sites that we have in the UK, often these are sites that have lots of civil infrastructure on them. And so that makes these sites very dense, but it means there's a lot of assets and infrastructure that we need to manage and maintain, in some cases to remain operational, and then we need to think about decommissioning those assets and infrastructure that we no longer need, and as we move forward. So it's kind of the scale of the problem is just the amount of infrastructure that we have to deal with moving forward. I think there is an opportunity from a research perspective to use new technologies, because there might not be a way of doing what the site operators want to do using conventional technologies. So it's being able to use new technologies that are being developed. And so my own research is in ground engineering and developing new grouting technologies, so technologies that are low viscosity, that means they can be injected at low pressures, and that's something that might be of interest on nuclear sites, particularly because they're so densely compacted, but also they have very strict ground movement tolerances, so you couldn't use other grouting technologies because of uplift and heave, and maybe you could use some of these lower viscosity grouting techniques. Yes, so we're looking at two different grouting technologies, colloidal silica grouting and also biogrouting, so using bacteria to precipitate calcium carbonate. And so these can be used in different ways. The colloidal silica, for instance, we could use to create hydraulic barriers, and that might be of interest for preventing migration of contaminated water away from site, for example. With the biogrouting and the precipitation of minerals, we could use this for strengthening the ground, but also you could use it for concrete repair. And there's a lot of degraded concrete at nuclear sites that might be able to benefit from this. So some of the benefits of a coordinated nuclear sector at Strathclyde and having links, the ANRC and having links with other universities is really about understanding what other academics are doing, both internally to Strathclyde and externally, and then having these links to industry as well. So through ANRC, I've become more aware of what partners other academics in, for example, the EEE department are doing, and have started another research project with them. Only today at the ANRC Nuclear Showcase, a representative from the Southwest Hub was able to tell me about facilities that at a university down in England that I might be able to go and use and test my materials at. So it's having that information readily at hand, and then also linking into the industry and understanding, what are the potential opportunities for deployment of some of our technologies and what are the real challenges that industry face.